so up here, this happened in the notes today. So in the beginning of your homework, there's four questions that just say factor. There is no, you know, nothing to simplify after that. Well, I'll wait to the last one that I do. And this is what I used as an example for difference of two squares. Really can't help if you still don't know how to factor here and don't remember this from before, because all this is just a difference of two squares where trig is the variable. So secant is like, or secant squared is like x squared. And one is a perfect square of itself, so that's why this all works. So secant times secant, good FOILers, good factors. Secant squared, positive secant and negative secant cancel, and negative 1 times 1 is negative 1. So yeah, it was real problematic, people not just being able to figure out how to factor back in the day. So if you know how to factor and you remember that, this should not really be a big deal. Oh no, this is one of those where it's a tough MA. This is just emulating the type of factoring where we had this. It really is. Oh, brother. Okay, so how did I factor 4x squared plus 1x minus 3? Remember back in the day, that was that MA, where m is not negative 3, m is 4 times negative 3. Now, this is a trick. It really is. It's reversing foiling. I would hope many of you could just figure out what are the parentheses. You know, like what multiplies to 4x squared, and that would be either 4x and 1x or 2x and 2x, so on and so forth. But I got to get rid of that. You have to get this figured out that that is working like x. All right, so that's, we're going to use the same terminology and actually factor that, but use tangent as our variable, not x. So I have a feeling, ooh, maybe I'm wrong. I think it is 4x and 1x, but watch what happens when we do our MA thing. So what multiplies to negative 12 and adds to be 1, 4, and negative 3. And I wrote that in reverse. So 4 times negative 3, 4 plus negative 3. Back in the day of factoring, you split this up into two terms. But I really hope, I know there are many of you that can just unfoil. I really hope you can just figure out what are the two sets of parentheses that FOIL to be the question. Those that are that good at factoring, hopefully that is doable. If not, then what you have to do is split up the middle term. So I do want to highlight this. Negative 3 plus 4, negative 3 times 4. Those are those, you split up the middle term using those magic numbers. Then you group and you factor out a GCF. This is so weird, right? The only thing that I can factor out in the first one is a tangent of B. That's a GCF. And that leaves for tan, yay pen, tan squared, minus 3, because I pulled that tan out. Then the only thing you can pull out of the second set of parentheses is 1. You do want to pull that 1 out so you can see what's left over here. And then this is like a binomial GCF. I always like to think of it that way. I think a lot of students don't. They just write the final answer, but it is true. I can pull that GCF binomial out, and I'm left with tan B plus 1. That's what I was doing when I was kind of thinking out loud. Many of us don't need all of that. You can try and figure out, all right, what equals 4 tan squared? It's either 2 tan, 2 tan, or 4 tan and 1 tan. And then what equals negative 3? Negative 1 times 3 or negative 3 times 1. And then you put a combination together that makes the FOIL, make the factoring correct. Whatever, that is factoring that one. That one's the longest of the ones that we have. This one is a smaller MA because I have 1 cotan to the 4th, bummer. So 1 cotan to the 4th plus 3 cotan squared. Well, this is a form of, factoring in x squared plus 3x plus 2. If I change this to squared into the fourth power, this would still factor a parenthesis times a parenthesis. And this one, you just go right for the parentheses because this is a simple MA. What multiplies to 2 and adds to be 3? 2 times 1, 2 plus 1. Not really a big set of numbers there. But instead of x, you would put x squared here, but it's not x. It's cotan to the fourth. So you put a cotan squared here. So treating trig exactly like variables. Good FOILers, good factors. Cotan squared times cotan squared is cotan to the fourth. This is 1 cotan squared and 2 cotan squareds, 3 cotan squareds. Good. And then 2 times 1 is 2. All right? So that's it. It just says factor in this section. You don't do anything else. Well, except for the, oh, wait a minute. You know what 1 plus cotangent squared is? It's cosecant squared. And that one doesn't really simplify it, but, you know, it is true that you could write that next possibly. Kind of weird. All right, here we go. And then this one's going to take a few minutes here because this is a sum of 2 cubes. And this was a formula. Soap. Soap is for the sines. Soap, same. And it's a times a plus b, sorry. So the perfect cube of a and the perfect cube of b cubed, sorry, a cubed and b cubed. And then this first term is the first term squared. Opposites, that's what the O stands for. The next term is 2 a and b's, or the a b's multiplied together. And then always positive. And then the last term is b squared. And then I did a long proof of why, if I were to multiply this, I'd come back and get a cubed plus b cubed. Hey, by the way, if it was a difference of 2 squares, the only thing that changes is those 2 signs. That's true. Same, opposite, always positive. So that will help you on a particular number that I assigned on the homework. We'll see where we'll go with that though. Okay, but then something weird happens with this one. So the perfect cube of sine cubed is sine. The perfect cube of cosine cubed is cosine. First term is the first term squared. Okay, so sorry, same, opposites. All right, this is getting in my way. Yeehaw, Cowboy Samuelus. Okay, but I didn't want to not see it anymore. There we go. Minus these 2 terms multiplied together. Sorry, there's no students in here, so I can not have my mask on. And then always positive. But then you're going to be mad. The last one I said you could have changed something, but it doesn't simplify it, maybe a little bit, not a big deal. This one is a must. Boom, boom. What does that equal to? 1. I was waiting for you to say it. I heard you out there. You can hear me? That is 1. So now that's weird with trig. Through a Pythagorean identity, this kind of actually got a lot smaller. But anyway, the point of this was to go over the factoring, and then some unique identity came out that made this even shorter.